Welcome back, Math 10s. We are going to be introducing domain and range in 4.4 here. These are new concepts. They are related to functions and relations. So let's check it out. So the domain of a relation or a function is the set of all possible inputs. Okay, what inputs are allowed? And very often this is X for what we're doing. Okay, and the range is the set of all possible outputs. Again, very often that's going to be y or f of x if it's in function notation. So really simple, we're going to look at a set of ordered pairs here. We want to know what's the domain, what's the range, and whether or not it's a function. So we look at our domain. Our domain are the inputs. So in green here, here's all my inputs. It's always the first number going left to right. So my domain is going to be -2, -1, 0, 1, and 2. And my range, let's see, we have, looks like, let's change colors, sorry. My range, I have 4, 1, 1, 5, and 4. So we don't have to repeat numbers. So it looks like let's just go from lowest to highest always. So we always want to go um, from low to high when we're listing our domain and functions. So our low looks like it's 1. And then we can also have a 4 and a 5. Okay, now, is it a function? Well, let's take a look. We look at all of our inputs, okay, and none of our inputs repeat. Okay, so none of our inputs repeat, so there's definitely not going to be two different outputs for one input. So this is yes, we do have a function. All right, now this function above is called discrete. Okay, it's called, sorry, it's supposed to be an I. Let's rewrite that. Is discrete. Okay. And notice that there are only 5 inputs with 3 outputs, so we can list them all. So let's actually graph these, okay? So I'm going to take each of these coordinates, I'm going to graph them, and it's called discrete because they're separate coordinates. They're not joined with a smooth line or a continuous curve. So the first point here was, I'm just going to be doing each of these. This was -2, 4. So -2, 4 is right here. And then -1, 1 would be here. 0, 1 is right here. And then we have 1 and 5, so way up here, and then 2 and 4, which would be right here. Okay. And we can see that now that I've graphed it, yep, sure is a function. It passes the vertical line test. And what would happen though if we connected these coordinates to create what's called a continuous? So if we attach these somehow, so I'm just going to do that with a dotted line. Let's say we attach these like that. We would be called a continuous function. Okay. And then, so how could we possibly write all the possible inputs and outputs when there are infinite? Because in between all these points, there are infinite points. You can add more and more and more decimals if you wanted, and there are infinite points in between every one of these points. So how could we take this continuous function, okay, not just coordinates, not just dots, and represent them all? Well, we're going to be using what's called inequality symbols. Okay, now you might recall these from middle school. The first one is less than, the second one is less than or equal to. The third one here is greater than, and the last one is greater than or equal to. Again, the idea of the greater than or equal to gets the extra line below the or equal to. And the absolute best way to remember this is that this one and this one, they have a L shape. Okay, so that tells you to say less than or equal to. And if it doesn't have the L type shape, kind of at an angle there, it's greater than. I want you to move away from I know there was a long time ago you might have learned these things and you would say, well, 5 is greater than 3. And you were taught something that might have been like the alligator. If you drew a little alligator here, right, and his little eyes, it kind of looks like a dinosaur now, but eats the bigger number. Okay, nothing wrong with that analogy. But the thing here is we're going to be using variables, and it's much easier to think of it as less than or greater than in the English language. Okay, so let's look at these on just a linear setup before we look at XY graphs. So right here, we want to write the following in words and in inequalities. So what we're having here is we notice that all the values, they go on to infinity negative here, but they never get more than 7. And because again, the open circle here from last lesson means it doesn't include -7. So the way to look at this is we can say this is our x values, everything to the left here. So we're going to say x is less than -7. It's not less than or equal to because of the open circle. Okay. Now you could also write this if you prefer to say -7 is greater than x. Works the exact same thing. Notice that everything has been flipped. The inequality symbol and the x and the -7 have been flipped. Both of those work. A little key thing, if you have an open circle, okay, that means that we're going to be using greater than or less than. If you have a closed circle, it means we're going to be doing greater than or equal to or less than or equal to. So put a little cloud around that. This generally important little things that are good to memorize. Okay, so in our next one here, we see x is, we have a closed circle here, okay? So it's going to be starting at 6 and it goes infinity above it. So we're going to say x is always greater than or equal to 6, no matter where I go on this line to infinity. Okay, again, it could be written as 6 is less than or equal to x. Either way, x is representing our line in the arrow and closed or open dot, okay? And then that's the restriction that's been put on it. It can never go below 6 in this case. Sometimes we get an interval, and in an interval, the best way to write that is set up your boundaries. So your boundary here is at -5, and my other boundary is at 1. So I like to think of it, okay, now what do I write in between? Well, -5 is less than x. Again, we're using less than because of the open circle. And x is also less than or equal to 1. So if I write this a little bit smaller, basically we're saying -5, writing the same thing here, but just a little tighter. -5 is less than x is less than or equal to 1. So we can think of these as -5 and 1 are the two boundaries, and x can be anything in between them. Okay? Now, let's look at a few graph examples. We're going to state the domain and range and determine whether or not it is a function. So domain, remember, the best way to remember is D comes before R in the alphabet. So this is the alpha, alpha for short. And X comes before Y. So a really easy way for like, what's domain again? Well, that's all possible X values. So this is our X and this is our Y always on our graphs. If you mix those up for some reason on a graph, remember X is like a cross, okay? So it's the line that goes across and X looks like a cross. Okay, now, let's just look at our x value. So the way to look at that is we look at our x boundary. So we have a closed circle, and if I go straight up, okay, this is telling me that the value is at -5 right here. And if I go over here on the right boundary, if I go straight down, that this value here, it tells me is at 2. So we're going to be setting up one of those with two boundaries, that and that. And because of the closed circles, it's less than or equal to x is less than or equal to 2. So x falls in between those two values. Our range, let's just switch colors, maybe go to red. Similar idea, we get the bottom boundary, okay, which is right here. We're told that is at -4. And we get the top boundary, which is right here, and we're told that is at 3. So there are that's our interval for our y. -4 is less than or equal to y is less than or equal to 3. And yes, of course, this is a function. It passes the vertical line test. Next, we're going to go to this domain and range. So this domain, I'm going to go straight up on the left boundary and see that's at -3, and it is a closed circle down below here, so that's less than or equal to x. And this one stops right on my x, and it's an open circle, so it must be less than 2. Again, we'll switch colors here and we'll look at my y's. My y lower boundary here is at -5, and my upper boundary looks like it never goes above 4. So we have +4 up there. So we have -5, closed circle. So we have less than or equal to. My y is less than or equal to my 4 because it goes right to the top there. Again, passes the vertical line test, so it is a function. Okay, a few more examples, we'll be done. Again, here my domain, it looks like the left boundary is -4, the right boundary is +4. So I'm going to have -4 is less than or equal to x is less than or equal to 4. Because of the closed circles, I'm using less than or equal to. My y boundaries looks like it covers from 0 here all the way up to 2. And that's going to be, that's going to be 0 is less than or equal to y is less than or equal to 2. Take a look at this one. The labeling's not that great. This point here is the main thing we need to know, that is at x equals -3 is right at that point there. So our domain, we can see this one's a bit unique, goes on forever. That's what the arrow indicates. This line keeps going and going and going. This line keeps going and going and going. So we can see x-wise, there is no boundary on the x. It goes to infinity. So the way we represent that is quite simple. We just say x must be greater than or equal to -3. Okay, there is no upper boundary. Next, we can, again, remember, you could write it this way. I should note that. You could write it as -3 is less than or equal to x if you prefer. The range here, is going to be something new and unique. We see that our range has no upper boundary because it keeps going up. It has no lower boundary, it keeps going down. And we're going to use a brand new unique symbol. And the way we do that is we say y, and this symbol is called epsilon, but we actually say is an element of, and we do this double line or bold R, and that stands for all real numbers. So let me take what this actually represents. I'll write it over here. Okay, so we have y is an element. That's what that strange E looks like, that curved E is an element of, okay, so this whole part is the epsilon, okay, it's a Greek letter, of all real numbers. And again, all real numbers is a quick way of saying, it's here again, that's the R. All real numbers is a quick way of saying, basically, we could have wrote negative infinity is less than or equal to y is less than or equal to positive infinity. But most often the syntax that we use in math is just y is an element of all real numbers, meaning y has no restrictions whatsoever. It can have any output. And this is not a function. Forgot almost to mention that. This is not a function because it fails the vertical line test in all kinds of spots. It passes 2 points. That's a problem. We don't have a function. It is only a relation. In the last one, it looks like I forgot. That one is a function because it passes the vertical line test. Okay, now this is another setup where we have 4 is equal to our y value here. So this time our x has no bounds. It can go forever to infinity this way and this way. So on our x value, there is no boundary. So x is an element of all real numbers. And our range does have a restriction right at the top at 4. It can never be above 4. So we're going to say y has to be less than or equal to 4. And this, of course, is a function. It passes the vertical line test. Next, we have a domain that goes forever in this direction, forever in this direction. So x has no boundaries, it has no restrictions. So x is an element of all real numbers. Likewise, if we take a look at the y, it also continues down forever and up forever. These threes are not significant in this question whatsoever. The y has no limitations. It also is an element of all real numbers, but this is not a function because we can just look at the y-axis here. It does cross at 3 different points, so definitely not a function. Okay, so a lot in this new, well, really not too much, because we need to understand how to use inequalities and what is domain and range. It's just a way of describing all possible inputs versus all possible outputs. All right, our x's and our y's, what's allowed, what's not allowed. We'll see you next time. Bye.